Hello, everyone, and welcome back. I am Dr. Flux, and this is General Psychology. I hope you're feeling refreshed and ready to dive into Module 2 Scientific Research and Ethics. We'll be exploring the fascinating ways psychologists study the mind and behavior. In this module, we'll uncover some basic methods that guide how scientific research helps us separate fact from fiction, and why that's so important. But before we jump into today's topic, let's take a moment to reflect on Module 1. Psychology is often divided into the ABCs: affect, behavior, and cognition. Which one focuses on feelings? Is it A, behavior, B, cognition, C, affect, or D, none of the above? The correct answer is C, affect. Affect refers to our emotions or feelings, an essential part of understanding human psychology. In Module 1, we discuss strategies for effective studying. Which of the following is a research-backed method for improving memory retention? A, rewriting notes repeatedly, B, using active recall, C, highlighting key passages in the text, or D, skimming material multiple times? The answer here is B, using active recall. Testing yourself on material rather than just rereading it is one of the best ways to retain information. Nice work! And don't worry if you didn't get those questions right, you can always revisit the earlier lectures to brush up. As we move into Module 2, I want you to think about this. Psychology is a science, but what makes it scientific? How do we move from abstract ideas to testable, reliable knowledge? Today we'll start by looking at the risks of pseudoscience, when ideas might seem scientific, but lack the rigor to back them up. We'll then look at how to operationalize psychological concepts. We'll take a look at populations and samples, and how we measure data over time before we conclude. But let's begin with a fascinating example: phrenology. What if I told you I could understand deep truths about your personality, intelligence, and future just by measuring the shape of your head? Sounds intriguing, doesn't it? Well, that's exactly what the proponents of phrenology believed. Phrenology was a pseudoscience that gained popularity in the 1800s. It was based on the idea that the shape and size of bumps on your skull could reveal your character traits and mental abilities. Imagine someone running their hands over your head and saying, "Ah, this bump means you're a born leader," or "This dip suggests you're not great at math." Phrenology might sound fascinating, but it lacked one critical thing: scientific rigor. Here's why phrenology failed as a legitimate science. It was built on faulty assumptions. They believed that different areas of the brain controlled specific traits, and that these areas directly shaped the skull's surface. Modern neuroscience has completely disproved this idea. It was filled with bias and subjectivity. Assessments often reflected the bias of the practitioner. For example, a phrenologist might find a trait that aligned with societal stereotypes of the time. There was also no empirical evidence to support phrenology. Phrenologists didn't have reliable data to support their claims. Their conclusions were based on anecdotes and subjective observations, not systematic experiments. Now, you might wonder why we're discussing phrenology now. It's clearly outdated. But the lesson is critical. Pseudoscience can mislead. It often presents itself as scientific, using technical language or appealing ideas, but it lacks the rigorous methods that make true science reliable. It can have harmful consequences. For example, phrenology has sometimes been used to justify discriminatory practices, reinforcing harmful stereotypes under the guise of science, not actual science. The failure of phrenology reminds us why systematic observation, experimentation, and data analysis are essential in psychology. Let's reflect. Have you encountered something that seemed scientific but lacked solid evidence? What caused you to be skeptical? Or why were you convinced? As we explore the scientific method in psychology, you'll gain tools to distinguish credible research from pseudoscience. Now that we've seen an example of pseudoscience, let's move to the heart of today's lecture. How do we approach reliable research? Psychology deals with concepts that are often complex and abstract. How do we understand ideas like love or happiness in a scientific way? The answer lies in operationalization. How would you study something as abstract as love? Imagine this. You're a researcher tasked with measuring love. Can you scoop it out of someone's heart and weigh it? Or maybe give them a love breathalyzer to assess how much love is in each exhale. Can you bottle it up? Can you translate the concept of love into a bunch of binary ones and zeros? This gets pretty tricky, but it highlights a big challenge in psychology. How do we scientifically study concepts that we can't directly observe or measure, like love, happiness, or stress? Operationalization is the process of taking an abstract concept, a conceptual variable, and transforming it into something concrete, measurable, or manipulable. It's how we turn ideas into testable data. It takes two important steps. The first is to define the concept. Clearly describe what the variable means in the context of your study. For example, if you're trying to study love, what do you mean by love? Is it a feeling of ecstasy? Is it a measure of attachment to someone else? Is it demonstrated by an action, like a hug? The second step is to develop a way to measure or manipulate it. Create a method for assessing or influencing the variable in a reliable and valid way. For example, you could count the number of hugs a person gives another person in a day to measure the amount of love that they're showing. Let's look at a few examples of how we might operationalize abstract concepts. For love, perhaps we could measure it by using a self-report scale where participants rate their feelings for a partner on a scale of 1 to 10. We could manipulate it by showing participants romantic movies to evoke feelings of love. For stress, we could measure it by checking heart rate or cortisol levels. We could manipulate it by giving participants a challenging math test under time pressure. For attraction, it could be measured by asking participants to rate the attractiveness and photos on a specific scale. It could be manipulated by having participants interact with someone deemed attractive or unattractive. Why does this matter? Operationalization ensures that research is reliable. Different researchers using the same definition should be able to get similar results. It also ensures that research is valid. The method should accurately measure what it claims to measure, and it should be replicable. Other researchers should be able to repeat the study and confirm the findings. For example, if we define stress by heart rate, other researchers should be able to measure heart rate in their studies and reach similar conclusions. Let's do an attention check. Which of the following is the best example of operationalizing the concept of happiness? Defining happiness as a general feeling of satisfaction with life, asking participants to rate their happiness on a scale from 1 to 10, telling participants to think about the happiest moment of their lives, or measuring participants' daily routines to infer their level of happiness. The correct answer here is B. Operationalization involves creating a concrete, measurable way to assess an abstract concept, such as using a rating scale to quantify happiness. Now that we've explored how to measure abstract concepts, let's turn to the people involved in psychology research. How do we decide who to study? That's where populations and samples come in. Imagine you're conducting a study on how social media affects CU Boulder students' mental health. Who are you studying? Your immediate thought might be all of CU Boulder. Well, that's your population, the entire group you're interested in. But here's the thing. Studying every student at the university would be impossible, or at least incredibly challenging. That's where a sample comes in. A sample is a smaller, manageable group selected from your population to represent it in your study. Samples are crucial because they let us make inferences about the larger population. But for those inferences to be valid, the sample needs to be representative. It should reflect the diversity and characteristics of the whole population. For example, if you're studying CU Boulder students' social media use, but only include students from the psychology department, your findings might not apply to students in engineering. A more representative sample might include students from across the entire campus. When it comes to sampling, let's clear something up that often gets confusing. Random sampling is how we select participants from a population. Every individual should have an equal chance of being included to reduce bias and ensure representativeness. Random assignment happens after participants are selected. It's how we place participants into different groups or conditions in an experiment, ensuring that each group starts out equal. An example of random sampling would include choosing 500 teenagers at random across the United States. An example of random assignment would include randomly assigning those 500 teens to low social media use or high social media use groups. Here's a quick thought experiment. Imagine you're studying how college students cope with stress. Which of these samples do you think is most representative? 100 psychology students from a single university? 500 students randomly selected from universities across the country? 50 students chosen based on who replied to your email first? The best answer here is the second one. Randomly selecting students from multiple universities increases the chance that your sample reflects the diversity of the population of the entire country. Using a biased or unrepresentative sample can lead to skewed results. For example, if you only study students from elite universities, your findings might not apply to students from community colleges or trade schools. If your sample lacks diversity, your findings might not generalize to the many different cultures that exist in your population. Next, let's explore 2 key ways psychologists study how things change over time. Human behavior is dynamic. It changes depending on when it's measured. To understand these changes, psychologists used 2 key approaches: longitudinal studies and cross-sectional studies. Each method offers unique insights into how people grow, develop, and respond to different experiences. Longitudinal studies involve following the same group of participants over an extended period, collecting data at multiple time points. This allows researchers to observe how variables change within individuals. For example, let's say researchers want to study the long-term effects of childhood media exposure on aggression. In a longitudinal design, they might follow a group of children from age 8 to age 18, measuring their media habits and aggressive behaviors every 2 years. Strengths of this approach improve that it tracks development. These studies reveal how individuals change over time. They also establish temporal precedents. By observing events as they unfold, researchers can determine which variables come first and which are critical for identifying causal relationships. There are some limitations, though. Longitudinal studies can be time-consuming and expensive. Tracking participants over years or decades requires significant resources. Additionally, longitudinal studies often suffer from something called attrition. This is when participants may drop out of the study, which can lead to biased results if the dropouts differ systematically from those who remain. Cross-sectional studies, on the other hand, compare different groups at a single point in time. Researchers collect data from various age groups and analyze differences between them. Imagine studying how children develop language skills. Instead of following one group for years, researchers could collect data from 2-year-olds, 4-year-olds, and 6-year-olds all at once, comparing their vocabulary sizes. Some strengths to this method includes efficiency. Cross-sectional studies are faster and less expensive than longitudinal studies. There's no risk of attrition. Since data is collected at one time, researchers don't lose participants over time. However, there are some limitations. Cross-sectional studies can't determine temporal precedents. It's harder to determine cause and effect because you're looking at different groups rather than tracking the same individuals. There's also cohort effects. These include differences between groups that might reflect generational or cultural factors rather than developmental changes. So how do researchers decide which method to use? It depends on the research question. Let's reflect. Imagine you're studying how people's preferences for music change as they age. Would you use a longitudinal or cross-sectional study design? Why? Take a moment to think about your answer. Both methods have their strengths and limitations, so it's about matching the approach to the question. Today we explored the building blocks of psychological research, how we move from abstract ideas to testable science. Let's recap some of the highlights. We began with the risk of pseudoscience. Phrenology taught us an important lesson. Just because something looks scientific doesn't mean it is. Psychology requires rigorous, evidence-based methods to avoid the pitfalls of pseudoscience. We discussed operationalization. Abstract concepts like love or happiness can't be measured directly. Operationalization allows us to define and measure these ideas in a scientific way, ensuring reliability, validity, and replicability. We talked about the difference between populations and samples. We learned the importance of selecting representative samples from populations and how random sampling reduces bias. We also discussed this from a random assignment perspective, which ensures fairness in experimental conditions. We concluded by talking about measuring data over time. Longitudinal studies track changes within individuals over time, while cross-sectional studies provide snapshots of differences between groups. Both methods have unique strengths and limitations. Before we close, let's do a bit of review. Which of the following best describes operationalization? A. Using anecdotes to explain a concept. B. Turning an abstract idea into something measurable. C. Selecting participants randomly for a study. Or D. Manipulating a variable to prove a hypothesis. The correct answer is B. Operationalization involves defining and measuring abstract concepts in a scientific way. What is a key difference between longitudinal and cross-sectional studies? A. Longitudinal studies track changes within individuals over time, while cross-sectional studies compare groups at a single time point. B. Longitudinal studies are faster and less expensive than cross-sectional studies. C. Cross-sectional studies are more effective at establishing temporal precedents. Or D. Longitudinal studies avoid attrition issues that affect cross-sectional studies. The correct answer is A. Longitudinal studies follow the same participants over time, while cross-sectional studies compare different groups at one time. Psychology thrives on its ability to take the invisible, things like our thoughts and emotions, and make them visible through rigorous research. The tools we discussed today are the foundations of that work. Take a moment to reflect on this. The ability to question, analyze, and evaluate evidence is one of the most powerful tools you can have, not just in psychology, but in life. In our next lecture, we'll dive deeper into research methods, exploring how psychologists design experiments and interpret results. As always, thanks for joining me on this journey into the science of the mind. Stay curious, stay resilient, and above all, live life in flux. Flux out.